Hello. Hello. Today's lecture is on units and dimensions for entrance class. Units and dimensions. For entrance class. This is the first lecture on units and dimensions. And to deal with the units and dimensions, we have to define certain quantities. Number one, we need to know what is the physical quantity. And then we need to know how they are classified, classification of physical quantities, then types, and then we will try to understand dimensions of physical quantities and units. Okay, now first of all, what is the physical quantity? Physical quantity is that one which can be measured and expressed in numbers. Any quantity that can be measured and expressed in numbers is a physical quantity. Like energy, force, velocity, mass are all physical quantities. These quantities can be measured and number can be associated with them. For example, if it's energy, sometimes you may say, well, it is 100 joules of energy. 100 is a number that you associate with the energy. So anything which can be measured and expressed in numbers is always a physical quantity. Number second, what about the classification of physical quantities? Classification is as under, you see, classification is, if I put it like this, there are three types. One is fundamental physical quantity. Fundamental physical quantity. Second is what you call as derived physical quantities. Number third is what you call as supplementary quantities. Supplementary physical quantities. Only a few, of course. These are only few. These supplementary is only a few. Now, what are the fundamental physical quantities? And then what are derived physical quantities? Then what are supplementary physical quantities? Let me discuss them one by one. First of all, fundamental physical quantity are those fundamental physical quantities are those which are independent of each other, which are independent of each other. That is, they are not related to each other. They must be quite independent. And these are, or as you see, mass, length, time, current, luminous intensity, temperature, and quantity of matter, that's mole, that's mole. So how many in all? Mass, length, time, current, luminous intensity, quantity of matter. So 1, 2, 3, 4, 5, 6, and 7. Yes, there are 7. These are 7 in all. Now you see, we write for mass, we write as m, and length we write as L, and then time we write as T, and current we write as A ampere, and luminous intensity we write as CD, candela, and then temperature we write as Kelvin, quantity of matter we write as mole. These are the all 7 physical quantities which are fundamental. Now, what about the derived physical quantities? Of course, these physical quantities, maybe mass, length, time, current, they're quite independent of each other. I mean, there's no relation between mass and length, time and current, this and that. They're quite independent. Now, let me go to derived physical quantities. Derived physical quantities. Derived physical quantities are those which are expressed in these fundamental physical quantities. I mean, any derived physical quantity contains these m, l, t, cd, mole, all these 7, maybe some of these 7, maybe only 2 of these 7 physical quantities. So derived physical quantity is one which is derived out of these fundamental physical quantities and are expressed in them. Derived physical quantities are expressed in terms of fundamental physical quantities. Physical quantities. Through their definitions, through their definitions. I mean, when you define a physical quantity, only then you can express them in terms of mass, length, and time, and other fundamental physical quantities. That's very important, because if you are not able to define a given physical quantity, then obviously you cannot express it or put it in the basic fundamental physical quantities. Okay. Now, then comes supplementary physical quantities. Okay, before we go to the supplementary physical quantities, let me give you some examples of these derived physical quantities. Now see, suppose area, it is defined as length into breadth, maybe. Both are lengths, so it is L square, it is derived. Suppose volume is there, It is length into breadth into height. All the three are lengths, L cube. Then there may be momentum. Momentum. It is defined as mass into velocity. It is mass is m, fundamental. Velocity is distance by time. It is m, distance is L because it is length, and its time t. Can be it is m L t minus 1. So this is a derived physical quantity. It contains fundamentals, and fundamentals, because m, L, t are fundamentals. So this is derived because it is expressed in fundamentals. And fundamental is not expressed in anything else because that is a fundamental. That's one more definition for a fundamental. Fundamental cannot be expressed in terms of anything else because it is itself fundamental. Okay. Now, let me go to supplementary physical quantities. Physical quantities. Supplementary physical quantities only few. Plane angle is a supplementary physical quantity. Plane angle. Theta. Dimensionless it is. And number second, solid angle. That is, okay, omega. Again, dimensionless. Because you see, let me work out why they are dimensionless. Angle between the two. Suppose these are the two lines. I want to find this angle. I will put this as an arc from here to here. Let this be R. Let this be arc length be L. This theta is defined arc by this radius. So it is length by length. It is dimensionless. Now, solid angle, that is defined as area. The area which subtends the solid angle by r square. There it must be area inverse, then it's r square. So again, dimensionless. Okay, now let me find the dimensional formulas and dimensions of certain physical quantities. Let me go to that point now. Dimensional formula, dimensions, and also dimensional formula of certain physical quantities. Let me go to that. Okay, let me start with, so first of all, I must tell you this thing. Suppose height, width, radius, and displacement, then distance, then thickness sometimes. They're all from here to here, they're all lengths. This you must know, and is expressed as L. Right? Now, let me go to number one, physical quantity. Let me start. Okay, let me do it afresh. Area. It is L into L, that is L square. Volume, that is length into breadth into, okay, height, that is again L into L into L. If you say a volume of a sphere, let me suppose that's 4 by 3 pi r cube. Dimensionless number, pi is also dimensionless, r is radius, it is again L cube. So whichever formula you pick up, you'll get the same dimensions, right? Now, number third, let me go to, okay, momentum again. Let me go to the momentum again, momentum. Okay, velocity. It is displacement by time. Yeah, okay, distance by time. Because any relationship you write, you must get the same dimensional formula. The way volume has this formula and the volume has this formula, both the formulas have given us the same dimensions. In the similar way, if you have a velocity distance by time or displacement by time, you'll get the same answer, time. It is L by T. It is LT minus 1. Okay, mass is missing here. That's also a fundamental quantity, but that's missing. So we can write m raised to 0, L raised to 1, T minus 1. So from here, I will explain you what is the dimensional formula and what are dimensions. See, well, the dimensions of velocity. The dimension of velocity are, see here, the dimensions of velocity are zero in mass, like this, 0 in mass, 1 in length, minus 1 in time. That's all. These are the dimensions: 0 in mass, 1 in length, this power, and minus 1 in time. And m0, L1, T minus 1 is called the dimensional formula. The dimensional formula for velocity. That's all. If you don't mention this m raised to power 0, that's right. I mean, you can delete this m raised to power 0 because anything raised to power 0 is 1. You can write L1 T minus 1. And if you don't even write this 1, because if this power is not written like 1, it is implied that L raised to power 1. So you can put it as simple as possible. This is all about this velocity. Now let me go to acceleration. Acceleration, fourth, acceleration. Acceleration is defined as change in velocity by time interval. Change in velocity has the same dimensional formula as velocity. Here you can learn one thing, that if a physical quantity has some dimensions, then change in that physical quantity have also the same dimensions. So here you can write LT minus 1. Again, T, time interval. So it is LT minus 2. So this is the dimensional formula. 0 in mass, 1 in length, minus 2 in time. And dimensional formula is LT minus 2. It is formula, dimensional formula. It's dimensional formula. Okay, let me go to the fifth. Okay. Number 5th. Let me go to density. First of all, we need to know the equation or the formula for the density. Otherwise, we are not able to find the dimensional formula. So it is mass by volume. So it is m by L cube. So it's ml minus 3. Now you can well understand dimensions and dimensional formula is this itself. So it is 1 in mass, minus 3 in length, and time is missing, so 0 in time. Now let me go to force. Let me go to force. So what I need to know first, I need to know on the formula for force. First of all, I need to know the formula for force. And then from the formula itself, I can derive the dimensions. This force is a derived physical quantity from basic fundamentals. So I can write well-known formula for force is ma, mass into acceleration. So it is nothing but, it is mass, it is written as capital M in dimensions, it is L minus 2. So this is the dimensional formula. And you can write, quickly you can write the dimensions. 1 in mass, 1 in length, and minus 2 in time. And dimensional formula is MLT minus 2. Now, seventh. Let me go to the seventh. Seventh is, okay, work or energy, okay, or, okay, let me heat energy, chemical energy, any form of energy, or even talk. All these quantities, work, energy, or torque, all have the same dimensional formula. So here we are going to learn something. When we get the dimensions. So work is, or energy, or whatever formula you write for work, whatever formula you write for energy, correct formula, you will get the answer. So work is force into displacement. Force is M LT minus 2 here. Into displacement is L. So it is M L2 T minus 2. This is the dimensional formula. So this dimensional formula belongs to all sorts of energies. So if somebody asks you what's the dimensional formula for chemical energy, you don't need to derive the formula for chemical energy, or you don't even need to have an equation for chemical energy. You just write this, because this is the dimensional formula for energy. And all forms of energy have the same dimensional formula. So here I want to write a statement: similar physical quantities. Physical quantities have the same dimensions. Even different physical quantities may have the same dimensions. They may have, but it is must for similar physical quantities. Similar physical quantities must have the same dimensional formulas. Okay. Now let me go to seventh. Power. You have the equation work by time. Here work, you already know that's ML2 T minus 2 that we have just derived. It is again time here. It is ML2 T minus 3. It will go up. Okay, eighth, pressure. Pressure is force by area by definition. Now it is MLT minus 2 by L2. That is ML minus 1. If it goes up, T minus 2. Dimensional formula. Ninth. Let me go to angle and solid angle don't have dimensional formulas. And let me go to angular acceleration, or angular velocity. Angular velocity has got the definition angle divided by time, and it is just 1 by t, that is t minus 1, because angle does not have dimensions, and whatever does not have dimensions can be replaced by 1, a number. 10th, angular acceleration. That is angular velocity, okay, it is written as omega, angular velocity by time, change in angular velocity by time interval. Angular velocity is this t raised to power minus 1, and time is time, it's t minus 2. These are physical quantities, derived physical quantities, which we express in mass, length, and time. That is how we find their dimensional formulas. 11th. Now, let me go to torque. Torque definition is force into force arm. Force arms nothing but length. That's m lt minus 2. That is force. Arm is nothing but length. It is m l2t minus 2. The same as energy. Although torque and energy are different physical quantities, but they may have same dimensions as energy. It does have. It is 1 in mass, 2 in length, and minus 2 in time. Now let me go to, okay, let me go to gravitational constant G. Gravitational constant. Now this gravitational constant you can find from the Newton's law of gravitation. That is F, see, G m1 m2 by r square. This is the famous gravitational law given by Newton. So how can we put G as? G can be put as F r square by m1 m2 from here. So we write the dimensional formula for each quantity, for each physical quantity. So it's m l t minus 2 is for force. It is L square for length, and then it's m here, and again m here. M1 is m, m2 is m. Both are fundamental physical quantities. Can cancel one m. So G is m minus 1. Can put it up. Write it minus 1. So L3. This. And T minus 2. That is all. Now let me go to 13th point. Let me go to point number 13. Here 13 is specific heat. Specific heat. How to find this dimensional formula for specific heat? First of all, you just try to get the formula for specific heat. So you know specific heat is defined as heat given to the system per unit mass per unit rise in temperature. That's the basic equation. That's the basic equation. So what to do with it? Have a look. It is C equal to, this heat added to the system is nothing but energy. So we can write M L2 T minus 2. And here it is mass, it is M. It is temperature here. It is not delta T. It does not stand here for time. It stands for temperature. So you must keep your wits about 1. It is K, Kelvin. So this cancels off from here. So it is L2 T minus 2 K minus 1. Yes. So if you want to know the dimensions, you can write like this: 2 in length, minus 2 in time, and minus 1 in temperature, Kelvin. And dimensional formula is L2 T minus 2 K minus 1. Okay. Now let me go to okay, which point was this?
13.
Okay, good. Listen to me carefully. You are the only student online. Just ask me some questions so that others things can become clear to others. It's very good that you have come online. I'm very happy with that. But try to be silent, ask the questions, and let me try to answer those questions so that others are benefited, right?
Okay, sir.
Okay, good. Very nice. So let me go to gas constant. It is 14th. Okay. Gas constant. Gas constant is R, right? And we had to pick up the formula which involves this R. Formula is very important to pick up. But you can pick up any formula you like, because any formula which connects this R will give you the same dimensional formula. Now, see here, if I do one thing, you know, PV is equal to nRT, you have one equation.
Yes, sir.
You do have such an equation. Here, P is pressure, V is volume, N is number of moles, R is gas constant, T is temperature, P is pressure, V is volume. So I can write what is R equal to? PV
Yes.
by NT, right?
Yes, sir.
So what equation, what dimensional formula you have for pressure? That is, if I remember it now, it is ML minus 1, T minus 2. We just derived it. You can just refer to that. V is volume, that's L cube. N is number of moles, and is mole, basic fundamental, MOL. And T is temperature here. This T is not this T. You have to keep your wits about one. What it means. This T is Kelvin.
Yes, sir.
And it's M L2 T minus 2 K minus 1 when it goes up, and mole inverse. This is the dimensional formula. And these powers are the dimensions. You say 1 in mass, 2 in length, minus 2 in time, minus 1 in Kelvin.
Temperature.
Right?
Yes, sir.
Good. Very nice. Very good. Now, let me go to, is it, was it, it is 15th, I think. Okay.
Yes, sir.
15th, coefficient of viscosity. In order to find the dimensional formula for coefficient of viscosity, we have to pick up some formula which connects this coefficient of viscosity in that formula. So there are so many, but you can pick up one. Every equation will give you the same dimensional formula for viscosity. So why not pick up this force is equal to 6 pi neta RV. This is one of the formula of connecting viscosity, this neta. What is neta equal to? F by 6 pi
6
or
pi R.
good. It is M LT minus 2 divided by 6 pi is dimensionless because it is a constant, right?
Yes. Yes, sir.
All numerical constants are dimensionless. You can write it down, or
Yes,
I will
sir.
write it down for you. All numerical constants are dimensionless. All numerical constants are dimensionless. Okay, now comes R, that is radius, that is simply length. Then comes velocity, it's LT minus 1. You can put L, you can cancel. It is M L minus 1. This will go up. And it is T, it's minus 2. This minus 1 will go up as plus 1. It's minus 1. That is the formula.
Fine.
Isn't that right?
Yes, sir.
Good. Now, let me go to, is it 16th now?
Yes, sir.
Okay. 16th. 16th, I want to tell you something about. Okay, let me go do Planck's constant. Planck's constant. Now, you may ask me that you said numerical constants are dimensionless. Numerical constants are dimensionless, but this is a physical constant, right?
Yes,
Physical
sir.
constants are not numerical constants. So you can remind yourself of any equation you like. There is E is equal to H nu. You have lambda is equal to H by P. Any of these two equations will do your job. So H is equal to E by nu.
E-
Is energy, that is ml 2t minus 2 that we got just before, and frequency is 1 by t, inverse of time period. This t will go up. It is m l2 t minus 1, right?
Yes, sir.
You got the dimensional formula for this now?
Yes, sir.
Okay, now let me go angular momentum. Angular momentum is, okay, L dash I will write for that because L is already reserved for this dimension. So I should not confuse these things. So L dash is, okay, any equation you like, R cross P. R cross P, you have MVR. You have MVR sine theta even sometimes. So it is easy to pick up this one. So L bar is equal to MVR. M is capital M, V is LT minus 1 velocity, R is L. So it is M L2 T minus 1. Same as this, right?
Yes, sir.
So angular momentum and Planck's constant have the same dimensions, although they are
Yes.
not same physical quantities. Therefore,
But dimension
yes, different physical quantities can also have same dimensions. So
same dimension formula.
yes, Planck's constant and angular momentum, same dimensions. It is worth remembering they have the same dimensions. Okay, let me go to one more concept. There may be, you see, you have to do as many physical, you may have to do derive as many dimensional formulas as possible within some days. But now there's a second concept. This was first concept. Now second concept regarding dimensions. What is that? What is that second concept regarding dimensions? That second concept is homogeneity of equations. It's a very important concept, and by this you can solve many problems. Even in general physics, if you apply this concept, many things become very clear, and you can answer so many questions on physics by this concept. Homogeneity of equations. Homogeneity of equations. I will give you some simple equations like L plus alpha, F minus beta. These are the two equations, right?
Yes, sir.
Good, very nice. These are two equations. So what does these two equations tell us? See, what do they tell? This tells us this L and this alpha have same dimensions. Because they have been added. You can add two quantities only if they have the same dimensions.
Dimension, yes, sir.
And this F, maybe this is force and this is beta, same dimensions. Why? They have been subtracted.
Yes, sir.
Okay, so you can add two quantities, you can subtract two quantities only when they have same dimensions,
Yes,
right?
sir. Yes, sir.
Is that right?
Yes, sir.
And they give rise to, it's not, see, and they give rise to the same dimension. Suppose L plus alpha, same dimension, both have same dimension, is equal to something. Okay, let me suppose X.
Yes, sir.
This x has also the same dimension. You
Sir.
understand that?
Yes, sir.
So this L, this alpha, and this x, they all have the same dimensions.
Dimension, yes.
Suppose this f minus beta is equal to y. Here f, beta, and y all have the same dimensions. Suppose
Yes,
I
sir.
have x plus y plus z plus kt is equal to kt. Then x have the same dimension as y,
Y,
same dimension as,
Z,
and same dimension as,
KT,
yes, not k,
KT.
product as a whole, okay, minus fm. If I write, I must say dimension of x is the same as dimensions of y, same as dimension of z, same as dimension of kt, same as dimension of fm.
Okay, sir.
All these have the same dimensions. This is very important. See how? Let me tell you how it becomes very important, how it is going to solve problems. Okay?
Yes, sir.
Let me go to this. This is the second important concept. Let me go to number one. Let me just start numbering again. If I have alpha by t square is equal to fv plus beta by lambda square, this is an equation. And from here, I want to find the dimensions for alpha and beta. And t and f, no, it's x square, sorry, it's x square. And t, f, and x are known dimensions. T, f, and x are known dimensions because you know t is time, f is force, x is displacement. Is that right?
Yes, sir.
Okay. Just in a moment, I have to charge this computer. Give me a moment. So how to do it? Look at this. So what I can say from similarity and uniformity of these dimensions, homogeneity, dimension of this should be the same as this. Isn't that?
Yes, sir.
Should be the same as this.
Yeah, beta by x square.
All these must have the same dimensions. No, not that alpha have the same dimensions as f or v. No, this whole here quantity has the same dimensions as this whole quantity here, same as whole quantity here. Because this fv is added to beta by x square, not v added to beta by v square. It is this whole. So what I write, alpha by t square should be equal to fv. But now you may ask me a question. How you can write such an equation if it is plus here? I write alpha by t square is equal to fv in dimensions. Dimensionally, they are equal.
Yes, sir, dimension.
Otherwise, it is not wise to write this thing. Physically, it may be wrong because if this is equal to this plus this, how can I write this is equal to this?
Yes,
but I can write they are equal dimensionally. So what about alpha? Fv t square. So write f is equal to mlt minus 2. V is velocity, lt minus 1 and t square. ठीक? Velocity is also known physical quantity. This t square and t square goes, it is m L2
t minus 1.
minus 1. Similarly, you can find beta. So how can you find beta? So I will
Alpha
put
by t square is equal to beta by x square.
not this, because here you have to substitute for alpha. You equate this is equal to this.
Yes, sir.
What I write? Fv is equal to beta by x square. So
Yes, sir.
beta is equal to Fv x square. So it will be beta equal to Fm Lt minus 2, that is force, Lt minus 1 is velocity, and L square, because x square is displacement square, right? So
Yes,
it is
sir.
beta equal to M L and L square L4. T minus 1, T minus 2, it is T minus 3.
Minus one.
That is the answer.
Yes, sir.
You don't need to copy, you can just watch it again at your leisure time. ठीक?
Yes, sir.
Do you think that you are understanding everything?
Yes, sir. Yes.
Good, very nice. Now, second, on this homogeneity of equations. Now let me go to here. See, if I have an equation P minus A by V square into V minus B is equal to N or T, and I ask you what's dimensions for A and B. Dimensions here and here. So what should I write? Now, look at this. You can't start multiplying everything, anything, and get a complicated equation. If you apply your mind, you say P is pressure and minus A by V square. This P and A by V square must have the same
Dimensions.
because they are subtracted. Simply, they are subtracted.
Yes, sir.
P is equal to A by V square because they are subtracted. They must have the same dimensions. That's what we have stated earlier. So it is A is equal to PV square.
Yes, sir.
And then A is equal to, it is M, it is L, T, it's minus 2, it's minus 1 pressure.
Pressure. Yes.
Yes. It is volume, it's L cube whole square. So it is M, L6, L5. Why? It's L6, it is L minus 1, L5, T minus 2. It is all done within no time. Now, what about B? V is the same as B because they are subtracted.
Yes, sir.
Isn't that? So
Yes, sir.
B is equal to L cube.
L cube.
That's the dimension formula for B.
Yes,
Isn't
sir.
this very easy doing?
Yes, sir.
Okay. Now I want to give you some additional information about these dimensions, which are very useful. Third, additional information is, you see, theta, angle, or phase is dimensionless. Isn't that?
Yes, sir.
Because that is defined by arc by radius.
Yes, sir.
Both are lengths, therefore dimensionless.
Length.
Sine theta is length by length. I mean, sine theta is perpendicular by base.
Yes, sir.
Perpendicular by hypotenuse. So length by length. Dimensionless. So
Yes,
sine theta, cos theta, tan theta, all these trigonometric ratios are dimensionless. So not only theta, but sine of the angle also dimensions, cos of angle, they are dimensionless. Achha, not only that, exponential functions like e raised to power kx, suppose, it is total dimensionless. Why? Because you know value of e is, suppose, that is 2.71, something like 3. This is the value of e. So it's a number. So that is dimensionless. And if you have a power of something, I mean, okay, 4 raised to power 3. 3 is the power. What do you mean by 3? And if that's 4 multiplied how many times?
3 times.
3 times. So power of anything is anyway dimensionless. Because suppose there is 4 raised to power x. So what you say 4 is multiplied x times, does that have a meaning? The answer is no.
Yes, sir.
So power, whatever power you have of any quantity, when you raise it to power, this power is dimensionless.
Yes,
Because
sir.
power is the times that you are multiplying something. So here E is dimensionless, e raised to power kx is total dimensionless. Right?
Yes, sir.
E raised to power kx total is dimensionless. E is dimensionless, e raised to power x is dimensionless, kx is kx power is also dimensionless.
Dimensionless.
This is very important. Is x dimensionless? No.
No, sir.
Is k dimensionless?
Yes, sir.
No. This power as a whole is dimensionless. Please don't forget that.
Okay.
This power as a whole is dimension. This power is a number. Maybe x is length, but k is 1 by length. So that power is dimension.
Yes, sir.
Okay. Just say, you see, sometimes you write theta is equal to omega t.
Yes, sir.
Theta is dimensionless. What about omega t?
Also dimensionless.
Yes, but what about omega?
So also dimensionless.
Nay, it is the product which is dimensionless. The whole is dimensionless. Theta is dimensionless. Omega t is dimensionless. That never means omega is dimensionless. Omega t is dimensionless means, okay, let it be 1. Dimensionless written as 1 as a number. That omega is 1 by t. That is t minus 1. Omega has dimensions of time inverse. This is a time t. So the product is dimensionless. Try to understand these things, right?
Yes, sir.
Okay. Now, let me go to log. Log of x dimensionless. उसका वैल्यू खास होता है. log का कुछ भी ले लो तो कुछ वैल्यू होता है.
Yes, sir.
Log x is dimensionless. Log of anything, a, b, c by kt, maybe, is all dimensionless.
Okay.
Log of anything, m by n, is dimensionless. Right?
Yes, sir.
Because log of something is, it's a number. Not only that, log, this total is dimensionless. Log जिस पर ऑपरेट करता है, log of this thing, this m by n और this x जो log के आगे है, या a, b, c by kt, they are also dimensionless.
Yes, sir.
You please concentrate on this. Log of x total is dimensions, total is dimensions, total is dimensions. Not only that, log जिस पर ऑपरेट करता है, this x,
वो भी dimensionless.
ये भी dimensionless है. कभी क्या होगा कि log of suppose kt. I ask you, what's the dimension of k? You may say dimensionless. No. What is dimensionless? Kt is dimensionless.
Kt is dimensionless.
That is right as 1. So k may be 1 by t. That is t inverse. So that it will be easy to find it that way. If you know this whole quantity is dimensionless. I must tell you one more thing. Whenever there is something which is dimensionless, you can equate this to the 1 for convenience, because 1 is anyway a number which is dimensionless, right?
Yes, sir.
Okay. Now let me go to something else. Okay?
Yes, sir.
जरा इसका हम करते हैं कुछ. Alpha is equal to what concept? It was what number it was? 5th or 6th?
17th, sir.
17th was it?
Yes, sir.
Okay. Let me go ahead without numbers. Alpha is equal to f divided by v square sine beta t. Find dimensions for alpha and beta. Good?
Yes, sir.
How can you do it? First of all, dimension of this alpha is the same as what? Alpha dimension is the same as what? Alpha dimension is the same as the dimension of this whole right side.
Yes, sir.
Because there is no positive sign to say this plus and this and this.
Yes, sir.
Now, alpha dimensions are the same as f by v squared, because sine of beta t is dimensionless. Trigonometric functions are dimensions total. ठीक है ना?
Yes, sir.
This whole is dimensionless, sine of this. That is m lt minus 2 by, it is velocity possibly, lt minus 1 whole square. It is m lt minus 2 divided by L2t minus 2.
Yes, sir.
When you square it, right? This
Yes,
goes
sir.
off. It is m L minus 1. What about beta? Sine beta t is dimensionless, isn't that?
Yes, sir.
What about beta t? What about beta t? Okay, sine theta dimensionless. Sine theta is total dimension. What about theta? Dimensionless?
Yeah. Yes, sir.
अरे साइन थीटा भी डायमेंशनलेस है, एंगल भी डायमेंशनलेस है, अभी बताया आपको मैंने. साइन
Yes.
थीटा इज डायमेंशनलेस, थीटा इज आल्सो डायमेंशनलेस. तो व्हाट अबाउट बीटा टी?
Also dimensionless.
Dimensionless. What about beta? 1 by t?
Yes, sir. T
T
minus
minus
1.
1. That's why I told you these things are very important, and you can pick up these things to get the dimensions of anything you like. It becomes very, very easy if you understand that the way it should be. Okay, now let me give you an exercise for tomorrow. You do it at your own places.
Yes, sir.
Try to work them out.
Yes, sir.
And then possibly tomorrow I will solve these problems first before I go to the next lecture.
Okay, sir.
Exercise, home assignment. Home assignment. Number 1, alpha is equal to fv square by beta square log to the base e 2 pi beta by v square. Find dimensions by alpha and beta. Other things are known. F is force, v is velocity, that is known. F is force, v is velocity. उनका पता है ना आपको?
Yes, sir.
Second question. Pressure P is equal to 3f v square by pi square t square x. Check the equation dimension. Check the equation. इसके भी डायमेंशंस आपको पता है, ये तो प्रेशर है. इस राइट साइड के भी डायमेंशंस चेक करो और देखो क्या ये करेक्ट है डायमेंशन.
Okay, sir.
Third, force is given by मैं 4 ऑप्शंस लिखता हूं. F is equal to 2 rho v a by r square log of rho m by pi a r. B option, F equal to 2 rho v square a by r log of rho a by pi m. C, E force is equal to 2 rho v square a log of rho a r by pi m. D, E force is equal to 2 rho v square a by r square log of rho a r by pi m. ये जो log है ना, log आगे इसका तो डायमेंशन है नहीं.
Yes, sir.
पूरा
M.
log of something इसका भी. तो आप ये यहाँ चेक ही कर, या आपको सिर्फ इतना ही चेक करना है. अगर
Just last.
इसका तो करना भी नहीं है कि log आगे log तो ये डायमेंशनलेस. ठीक?
Yes, sir.
Is that right?
Yes, sir.
So it is not a difficult question. अच्छा बेटे, नफसी. Fourth question. Find dimensional formula for 1 by 2 epsilon 0 e square, 1 by 2 mu 0 b square, where E is electric field, B is magnetic field. Fifth, dimensional formula for 1 by LC. Sixth, RC का भी निकालो. Seventh, L by R का भी निकालो. Eighth, E by B का भी निकालो. Ninth, G epsilon 0 का भी निकालो. 10th, electrical flux by magnetic flux का भी निकालो. ठीक?
Yes, sir.
These are few questions. You work on them without any fear. And tomorrow I will give a lecture at 10 p.m.
Okay, sir.
Right? I will write that on the Facebook post.
Yes, sir.
And will you attend tomorrow's lecture?
Yes, sir. Inshallah.
तो बाकी लोग करेंगे because it is already recorded. They will listen to the lecture, or they will just watch the lecture. And tomorrow I will solve these questions first, and later I will do the next lecture. Okay?
Okay, sir.
It will take a few lectures and find it to be kind. But now see here, I have given you a lecture. But if you don't solve these problems by yourself and or try to solve them, then it is of no benefit.
Yes, sir.
In terms the physics, it is not how much you learn. It is not how many lectures you attend. It is how much you do, how much you
Yes.
practice, how many exams you appear in. There are students who appear in as many exams as possible and finally they get selected. So it is not all about learning. It's all about doing things by yourself, right?
Yes, sir.
Okay. So let me stop the lecture now.